Now that we've started to encounter some tri-substituted alkenes as the product of elimination reactions, this brings us to an interesting nomenclature question that we have not yet completely addressed, and we have to develop a new rule for. So with tri-substituted alkenes, it turns out that the cis and trans system that we have developed so far can be ambiguous. For example, is the following alkene cis or trans? Well, the methyl groups are trans to each other, but the largest groups, the methyl group and the ethyl group, are cis to each other. So what is this? Well, the way we handle such situations is we assign the two groups on each alkene carbon priorities, the same way we assign priorities using when we're evaluating R and S for stereocenters. So this molecule's name, at least without cis or trans, or as we're going to see E or Z, is 3-methyl-2-pentene. So the algorithm we're going to follow to assign this is first to assign a priority to each group on C2. Okay, so in this case, the methyl group is going to get priority 1, and the hydrogen is going to get priority 2. Same rules as for R and S. Carbon is a higher atomic number than hydrogen, so it's going to get priority 1. This is easier than for stereocenters because we only have to worry about 2 priorities on a particular carbon instead of 4. Next step is to do the same thing for carbon 3. So the ethyl gets priority 1 and the methyl gets priority 2. Because in this case we've got a carbon bound to the alkene carbon in both cases, so we need to move out one more atom to the first point of difference, and then we see carbon on the top versus hydrogen on the bottom. Now the rule. If the groups with priority 1 are on the same side of the double bond, we assign it Z. If they are on opposite sides of the double bond, we assign it E. And the place we put this in the name is we put the letter E or the letter Z in parentheses at the beginning of the name, and then we put a dash. So the full name for this structure would be Z in parentheses dash 3-methyl-2-pentene. So in terms of relating the E and Z system to the more familiar cis and trans system, any compound that is cis in the cis and trans system will be Z in the new system, and any compound that is trans in the cis and trans system will be E in the new system. So you could always use E and Z. Cis and trans are not always going to be applicable. And in case you're wondering where the letters E and Z come from, they actually come from German words, because much of organic chemistry's first century was developed by German chemists before World War I. And Z comes from the German word zusammen, which roughly translates as together, and E comes from the German word entgegen, which translates as across. So now you know where E and Z come from if you care about such things, but whether or not you care about that, I hope you will agree with me that using the EZ system of nomenclature is easy.